Good morning, everyone. In case you missed the first session, I'm Ollie Lancaster, IGEM's Chief Executive, and it's my great pleasure to welcome you to the second session of the 20th IGEM Young Persons Paper Competition Final. We've had some fantastic contributions so far, and next up we have another batch of presentations and learning for us all, covering hydrogen networks, safety, powering construction sites, guaranteeing the origin of hydrogen supplies, and odorization. As a reminder, we are recording this event and it will be available to view on IGEM TV afterwards. I can now hand over to the YPN chair, George Brookfield, who will once again chair the session and introduce the speakers. So George, over to you. Thank you.
Thanks, Ollie, and good morning, everybody. I'll quickly run through some of the other logistics for this morning's session, and then we can crack on and get into some of these excellent presentations. So only one of our stellar contestants can be crowned the winner and take home a once-in-a-lifetime trip to the World Gas Conference 2022 in Korea and have their name engraved on the prestigious IGEM YPPC trophy. Our finalists each have 15 minutes to present and 5 minutes to answer any questions from the judges. If you have any questions for the presentations, please submit them into the chat on the Teams. And if we have time within the 5 minutes, I'll ask them on your behalf. And if not, hopefully the presenter wouldn't mind going back through and answering them in the chats for the facility as well. So we're going to be listening to the next 5 finalists with a break shortly after for the judging process to commence. We will then reconvene, as you can see on your screens, at 1:45 to reveal the winner. But first, to introduce you to the judges, if you weren't able to get into the first session, we've got Ben Clark, who is Technical Director at WSP and our President at IGEM. He's also a past winner of the YPPC. He's joined by Andy McPhee, Chair of IGEM's Professional Development Committee, and Lucy Ritchie, Senior Client Manager of Energy at Energy and Utility Skills. So without further ado, I'd like to commence with our 6th finalist, Matthew Clue. Matthew is a project coordinator at Northern Gas Networks and is a member of the North Eastern Yorkshire Section Heat. He's the Heat winner, sorry. And the title of his presentation is H21 Pioneering a Hydrogen Network. So over to you.
Good morning, everybody. Can everybody see my screen okay?
Yeah.
It's just... So my name is Matthew Clue. I am the H21 project coordinator. I joined Northern Gas Networks in June 2020, which was mid-pandemic, and who would have thought 18 months later we would still be in the midst of a pandemic. So I'm going to be talking to you today about the H21 Pioneering a Hydrogen Network. First of all, what is H21? H21 is a suite of projects addressing the conversion of the UK's gas network to transport hydrogen. It is led by Northern Gas Networks, who deliver gas to 2.7 million homes and businesses in the North East, Northern Cumbria and much of Yorkshire. So, H21. H21 initiated as a feasibility study in 2016 under the Lead Citygate report. This report determined that it was economically feasible and technologically possible to repurpose the existing gas network to transport hydrogen. These results were released in 2016. The H21 programme seeks to demonstrate the suitability of the existing gas infrastructure to distribute 100% hydrogen. Reusing the existing gas network to transport hydrogen could lead to the least disruptive and the most cost-effective route to carbon-free heating for the majority of the homes. It would also make use of the vast assets and the ability to deliver the supply of gas, just like we do with natural gas. So, why are we undertaking this research? Climate change is one of the biggest challenges facing the world today. Over a third of the UK's carbon emissions come from heating our homes using natural gas. And the carbon dioxide emissions account for 65% of the global greenhouse gas emissions, which is a major concern, not for just our generation, but with future generations. The UK signed legislation in 2019 committing to a legally binding target of achieving net zero by 2050. This legislation further supports the UK Climate Change Act 2009, and it also has been supported in Boris Johnson's recent 10-point plan. Prior to the Lead Citygate report, there was little to none investigation in how to decarbonise the natural gas network. So as you can see here on the screen, phase 1 kicked off in 2018, which I'm going to discuss soon, and then we've also started our phase 2. The phase 1 is able to quantify safety-based evidence. The aim of phase 1 is to investigate and address the safety-based evidence for potential 100% hydrogen conversion within the UK distribution network. The aim of phase 1 was to deliver an optimally designed experimentation and testing programme to provide safety evidence to support the 100% hydrogen conversion. This was achieved through 4 work packages, which I'm going to discuss. The first work package was background testing. The aim of this background testing was to understand how background leakage may alter during a conversion to hydrogen. There may be safety concerns. Is there going to be a higher leakage of hydrogen? This will lead to more public reported escapes. This may have commercial implications due to the loss of hydrogen and operational impacts, as there may be more call-outs. This could lead to a reduction in public confidence. From this background testing, there were 214 assets recovered, which were representative of our current network. This included steel pipes, cast, spun and ductile iron pipes and PE pipes. There was also various fittings such as regulators and valves which are tested. A strategic set of tests were developed between ourselves and project partners at HSE and DNV. We found that from these 214 assets, that 174 of them did not leak. This meant that if they did not leak on natural gas, they did not leak on hydrogen. It was found that 41 of these assets did leak. However, only 19 provided sufficient data for leakage. This is due to the calorific value difference between hydrogen and natural gas. We found that if the assets were tight on natural gas, they would be airtight on hydrogen. If it leaked on natural gas, it would leak on hydrogen. The findings also shown that following repair, if an asset was then gas tight on natural gas, then it would be on hydrogen. As you can see here, there are 4 types of joints which were mostly responsible for types of leaks, which were hook bolts, lead yarn, threaded joints, and bolted glands. Moving on, so after undertaking the background testing and understanding the leakage, we had to move on to the consequence testing. Now that we understand how a background leakage may differ when using hydrogen compared to natural gas, we need to understand the consequences of this. This testing would allow the quantification of risks associated with background leakage of hydrogen versus natural gas. There were 3 critical areas identified between ourselves and project partners. The first set of tests was ground and concentration testing. The aim of this testing was to confirm how hydrogen would dissipate within the ground and air from network assets if there were a leak. This included small and large releases. The results were then compared to the historical gas data. These findings verified the associated concentrations of hydrogen in the ground and air as compared to natural gas. From understanding how the hydrogen would dissipate and migrate, we needed to understand the consequences of this potential migration. We need to understand how hydrogen may ignite or explode when exposed to a range of ignition sources, such as power tools, which the operational staff use, engines, and even cigarettes. There's also a need to understand the severity of these explosions. This programme of work focused on types of enclosures which are typically found within our gas network, such as meter boxes and kiosks. Again, the results were then contrasted against historical natural gas data. This fed into the quantitative risk assessment, which will be discussed later on in this presentation. The last work package, we need to understand how the operational activities on a 100% hydrogen network would be undertaken, as they are today with natural gas. These works were a preliminary insight into the operational activities. These operational activities focused on purging, isolation, and excavations. We needed to understand if the current operational activities could still be undertaken on a hydrogen network. So, after we've undertaken the phase 1 phase 1 work, now we needed to understand the operational safety demonstrations. After providing the safety evidence with hydrogen, The phase 2 commenced in January 2020, and the aim of phase 2 is to provide critical safety evidence to support the viability of a 100% hydrogen network. Phase 2 is a critical stepping stone, providing evidence which will underpin any future research into hydrogen and the suitability of our current natural gas distribution network for transporting hydrogen. This again was undertaken in 4 work packages. The first work package, the appraisal of network operations. This was split into 2 smaller phases. The initial appraisal of network operations, which was supported by our project partners over at HSE. The aim of this research was to provide an assessment of the basis of safety for hydrogen compared to natural gas. As you can see here, there was an initial review of 600 network procedures, 680 network procedures. They found that through a preliminary research, there were 8 key areas, as you can see here, which required further research. Within the 8 key areas, there's been further research undertaken, both desktop-based and with interviews, such as the human factors. We needed to understand the procedural changes which may affect our current operational staff. From this further research, there has been interim reports which were completed in March 2021. The interim reports helped develop a master test plan for testing on hydrogen. From the testing on hydrogen, which is being undertaken now in our year 2 work, any significant findings will help update these interim reports and will aid any future research into hydrogen network operations. So, the second phase of 2A. Was the microgrid build and testing. Within phase 2A, the construction of the microgrid based at Spade Adam, as you can see here, was completed on the 4th of June 2021. The microgrid is a purpose-built distribution network, which is a first for hydrogen. You can't really see it here, but the microgrid is made up with a kilometre of PE pipe ranging from 630 mil all the way down to 63 mil, and it consists of high pressure, intermediate, and low pressure tiers. Within the microgrid, there is use of repurposed pressure reduction units and valves. There is also here, as you can see here, a high pressure storage unit for hydrogen. The research is currently ongoing against the agreed master test plan, which was developed in the first part of 2A. This is focusing on the network operations up to 7 millibar, such as planned live gas operations, emergency responses, maintenance, as you can see in the bottom right, and pressure regulation. The testing began in June 2021 and is going to be complete in early 2022. The main learnings from phase 2A is to understand if the current gas operations and regulations are fit for purpose on the use of hydrogen, and to highlight what further research is required for training, policies, and procedures. We need to understand this to operate a safe hydrogen gas network in the future, just as we do in today's with natural gas. Following on from phase 2A was phase 2B, unoccupied network trials. This is a world's first section of decommissioned natural gas network, which is being repurposed to carry hydrogen. The site is situated at South Bank area of Middlesbrough. As you can see here, whereabouts it is situated. And in the bottom right, you can see what it looks like now with the construction nearing ending completion. This piece of research is a great stakeholder piece as it is situated with the public domain, so it can be seen by the general public. Even though they may not be able to observe the testing, they can see the testing being taken place, just like it does on today's existing natural gas network. As you can see in the bottom right of the image, the red lines show the existing ductile iron mains, which have been pressure tested and have been shown that they are gas tight, which means that we can flow hydrogen through it. With the yellow lines, this shows the new inserted PE pipe. If you can see here, this creates a hydrogen flow loop, which is fed from a high pressure hydrogen bottle packs, as you can see in the middle right there. From this, the high pressure hydrogen is reduced through a repurposed natural gas skid unit. The hydrogen is also then odorized. The odorization of the gas is going to smell exactly like natural gas today, again, which is a great stakeholder piece, as if there is gas leak in future on hydrogen and it smells just like natural gas, there's going to be no changes.
3 minutes remaining.
The aim of this testing is to undertake operational activities which happen day to day in our current gas network, such as leak findings, isolations and new connections. A great piece of this work is there's going to be 100% hydrogen boilers situated within the cabins, which will be the first time these will be tested on 100% odorized hydrogen. This will give the boiler manufacturers great feedback of what may need to change. Moving on to the quantitative risk assessment. This happens over phase 1 and phase 2. The results of phase 1A and phase 1B fed into the QRA. This is due to the different properties of hydrogen versus natural gas. There needs to be an evaluation of safety and risk to the public of supplying 100% hydrogen versus natural gas. Does hydrogen present higher or lower risks when compared to natural gas? And if it does so, how can this be mitigated? The research was based on real network assets, which was supplied by Northern Gas Networks. This research and methodology used, it was very cautious. We found through research that the risk of hydrogen fires were lower than natural gas. However, the hydrogen explosions risks of hydrogen fires were lower than natural gas, and explosions were higher than natural gas. But how could this be mitigated? Further research is now being undertaken within phase 2 to create a more robust basis of safety up to and including the emergency control valve, which is where the gas enters the building. This work is being supported by the High for Heat, which is funded by BASE, who undertook a quantitative risk assessment of hydrogen downstream of the emergency control valve. Combining both sets of this research will provide a more holistic prediction of the risks of hydrogen network versus today's natural gas network. And then we have the social sciences. Now we have all the experimental data. What about you and me? What about the general public who don't understand hydrogen? The aim of the phase 1 was to, currently there is limited understanding of public perceptions of hydrogen. There needs to be an understanding to the general public. This was done by undertaking questionnaires. And then as soon as we understood public perceptions, this moved on to communicate effectively with the public. We have done this by creating a glossary of terms, and as you can see, if you scan this QR code, this will take you to a presentation about explaining how hydrogen is produced and the positive impact about using carbon dioxide. So my role within H21, I'm a project coordinator. I support project managers on the day-to-day running of the projects. I monitor the progress, highlight the good work we're doing, and highlight any delays. I've improved the financial tracking capabilities. As some of you may be aware, SAP can be a nightmare. However, I understand SAP and I can understand the financials. I support with the new creation of new projects, which are further supported in phase 2. And I've recently started project management.
I'm afraid that's your time up there, Matthew. Okay. Apologies to cut you short. But you know, you've packed it in there, some excellent detail. Can
I just say one more thing, please?
Go on, and it's going to be very quick.
Okay, the aim for H21 is to be delivering 100% hydrogen to a village trial by 2025. Thank you, and I'd like to take any questions.
Okay, thank you very much, Matthew. Yes, over to the judges then, please, for your questions.
No problem. Lucy, would you like to go first this time?
Yeah, very quickly. Thank you, Matthew. That was a fantastic kind of high level overview of the H21 whistle stop tour, and at the end you just started to talk about your personal involvement, and I think really my question was, where did you fit in? And I think you spoke very passionately, and I sense that you're very excited to be involved in this. What's your biggest takeaway so far, I think, Matthew, from a personal perspective?
From a personal perspective, I don't have any experience within the gas industry. So when I joined 18 months ago, gas was completely new to me, and so I think it's been having that opportunity to learn on the job and having the support of a wider team, where if I don't understand a particular question, or I can always ask. It's all about learning, and they're very supportive. And sort of within my role, I ensure communication between key stakeholders, such as a wider business and even our subcontractors. So it's sort of really putting myself out there and really just jumping in with 2 feet.
Well done, fantastic answer, and you would never know Matthew, you would never know that you haven't got a background in the gas industry. So that's it for me. Thank you.
Excellent. Thank you very much, Matthew, and excellent presentation. My question for you is looking ahead, and appreciate that you know, just in terms of what you've just said, you know, you've not had only had 18 months, but based on the work to date, there's a number of different factors that are going to come into the hydrogen economy. There's the technical, there's the safety, you know, there's the commercial, and there's also, but you know, there's the consumer. Out of those sort of, you know, what you've seen to date, what do you think is going to be, what's the biggest challenge coming up, and you know, based on your own personal reflections of what you've seen to date?
I think for myself personally, so at the moment on Friday, every gas distribution network has been invited to submit a bid for hydrogen village trials. And with managing the safety case review, there isn't a GSMR for hydrogen, or there isn't a safety case. So highlighting what sort of work needs to go into that, so we can provide HSE with enough supported evidence that hydrogen actually can be used as a gas for distribution. There's a lot of work, and in a small space of time, it's how are we going to manage to do all that?
Yep, squeezing it all in. Thank you very much.
Yeah, exactly.
Well,
Andy,
you've already answered my question, which is the same as yours, Ben. But just picking up on the social science side, he didn't really have much time to cover that. Do you want to say a few more words about that?
Yeah, so for the general public, I class myself as a general public, not a gas expert. And so for me, if we don't understand what hydrogen is and the proposed benefits, the uptake may change, or it may not be as well received as we would like. I like to refer to the whole point of like when we changed over from to digital TV. So there needs to be a lot of work gone into that, like lots of advertisements, so that people are aware that we are changing from natural gas to hydrogen. And we have the hydrogen home situated up at Low Thornley, which is using 100% hydrogen, and people can go there and visit. And there's no difference between using hydrogen and natural gas. The only benefit is that there isn't any carbon emissions, which for my generation and future generations is the most important thing.
Right, thank you.
excellent. I think that's us, George.
Yeah, thank you very much, guys. We do have 1 minute left of this part. If anybody's got a question, if not, I have a quick one to fill this minute. Matt, what are you most looking forward to then in the future? What's the next 12 months got in store for you?
I don't know if you're referring to the Young Persons Network there. However, we are going to be completing our phase 2, hopefully come June 2022, and I will be taking over from George as the chair of the Young Persons Network in May. So I'm very excited to hopefully grow the Young Persons Network within IGEM and work alongside George. But I think work-wise is definitely getting phase 2 completed and getting the research out there, so everyone can understand the learnings. Great. Yeah, no, good answer. Thank you. All right then, Matthew, thank you very much. We shall proceed with the 7th finalist. Just share my screen again. Yeah, thank you, Matthew. Thank you, judges. So I'd now like to hand over to Jodie McAvoy. Jodie is a network controller at Wales and West Utilities and is the heat winner for Southwest section. The title of Jodie's presentation, as you can see on the screen, is The Human Factor, Managing Safety Critical Tasks on the Gas Distribution Network and Performance Influencing Factors. Over to you, Jodie.
Thanks, George. Bit of a mouthful, isn't it?
You nearly got me.
Nearly got you. Okay, just one sec. I'll just share my screen. Just one moment. Can you just let me know if you can see my screen?
Yes, we can do. Thank you.
Is that all good? Wonderful. Yep. Okay. So good morning, everyone. My name is Jodie McAvoy and I work for Wales and West Utilities. Even though I'm technically a young person, I've managed to rack up 15 years experience in gas distribution. I've worked as an admin assistant in connections, customer service, where I was a high-level complaints handler for safety-related complaints, moving into system operation, where I specialise as a gas safety engineering assistant. For the last 3 years, I've focused on process safety, as safety of my colleagues and the public is very close to my heart. Managing the safe control of operations, the topic of human factors and managing safety critical tasks on the network is one that I'm really passionate about and excited to share with you all today. So before I dive in, what are human factors? It's probably a good place to start. So these are the environmental, organisational and job factors, as well as our own individual characteristics, which influences our behaviour at work and affects our health and safety. So job factors can include the nature of a task, our environment, or even our workload. Organisational factors are our work patterns, our culture, resource, even our leadership. And those individual characteristics are our own competence, our skills, even our personality and attitude can influence this, but essentially our risk perception. So the HSE takes a topic-focused approach to human factors. These are by no means in a priority order, but you will certainly recognise these as hot topics for a major accident hazard industry. I could spend the rest of the day going into every one of these, so I'm just going to focus on one, organisational change. So we're now in a new price control and responding to net zero targets. There's a continuous need to adapt and evolve our business objectives. Organisational change, such as preparing for and using hydrogen in our network, means we need to manage change effectively, as well as adapt our approach to managing associated hazards and risks. If we don't do this, it can impact on the performance of our people and could possibly sadly result in a major accident hazard being realised. Unfortunately, a number of those top 10 factors are usually not in isolation, and they can all contribute to significant incidents being realised or a major accident hazard. Therefore, we need to recognise the importance and value of safety critical task analysis and being able to identify human failure and optimising those performance influencing factors. So I first got involved in this project back in May. I was tasked to prepare for a HSE baseline assessment on how we manage human factors and safety critical tasks on our network. We prepared by reviewing the Energy Institute guidance and the competent authorities guidance on human factors. Although we're an industry leader on safety, we did acknowledge that we weren't quite where the HSE expected us to be on how we manage human factors. We can manage risk, but there's a lot more that we could have done and that we can do. So after the assessment, I tasked myself to develop my own knowledge in June. Although I'm aware of risk assessment and managing risk, I wanted to really get my teeth into this subject. So I wanted to become an informed customer. So enrolled myself quickly on an Energy Institute training course. In July, we had the outcome from our baseline assessment from the HSE, where we received 2 actions. The first, to develop a procedure and our methodology on identifying what are our safety critical tasks and how we're going to assess them, but also how we develop, maintain and review safety critical documentation for these tasks. When we went into this intervention, we were very much geared towards coma, as that's what the guidance quotes. We have 3 lower tier coma sites on Wales and West's gas network, but we soon came to realise the HSE's expectation was the entirety of our gas network in the lens of gas safety management regs. That was quite a bit to swallow, as that could potentially mean hundreds or thousands of assets that could potentially be analysed in terms of the tasks we carry out every day. So in August, I set about communicating and sharing my knowledge internally in Wales and West, so that we can understand the risks that this could involve. You know, there could potentially be thousands of things that we would need to analyse, but also understand the benefits. And once we understood those, I was able to achieve leadership buy-in to continue this bit of work. So in September, I wanted to share this with wider industry, so I engaged the Gas Regulation Group and the Gas Networks Collaboration Forum, because we understand there's some wins to be achieved across the wider gas distribution networks, and there's learning that can be adapted between all of us. And we're also pretty much wanting to get the methodology right if it's going to consider the entirety of the network. In October, October, we completed a tender process to appoint a human factors consultant. This is a new area for us and we want to get it right. So we do need a specialist to help us develop our methodology and embed it in the business so we can become independent in the future. So this was all scoped up in November. I took our specialists out to a number of our sites. We went to an offtake, coma site and a project. And I wanted to share the knowledge as well with frontline staff so that I can prepare the workforce for what is to come. In December, I'm pleased to say we're on track to develop the first action or complete the first action of a procedure, setting out how we identify safety critical tasks. And we've even got a workshop taking place tomorrow, which we've invited the health and safety executive to attend. So maybe a future presentation on that, maybe next year, who knows. So what is safety critical task analysis? It actually has a long history. It was first developed in the 70s at Shell Stanley Refinery as a procedure and competency methodology. But over the last 50 years, it's evolved to become what we know today as safety critical task analysis and been adopted by the HSE. So this is a human factors roadmap, which is taken from the Competent Authorities Delivery Guide, and it sets the framework for reviewing safety critical tasks and analysing those failures and the human factors around those. You'll notice at the bottom or at the beginning of the roadmap, it mentions local major accident scenarios. This is coma-centric language, and we really do want to develop that in Wales and West to be Wales and West specific, in line with the HSE's guidance and for us to do the right thing. So we need to establish what our safety critical tasks are in relation to the business. So with the expectation this is applied across the entirety of the network, as I mentioned, this could potentially lead to thousands of tasks that need to be analysed. It's fundamental that we establish a suitable screening process to ensure we're focusing on the highly critical tasks in our network most susceptible to human error. This could involve multiple fatalities, major loss of containment. We need to make sure that if we're going to do it right and analyse the most important to us. So once we prioritise our tasks on a safety critical task register through screening, we can start our programme. We understand the task through hierarchical task analysis. Oh, there we go. Here's our Wales and West scenarios at the beginning. We need to firstly analyse the task through hierarchical task analysis, establishing work as done. We then can look at human failure, how we contribute to things going wrong. But firstly, we go to the left of the roadmap. Can we remove the human failure through a hierarchy of control? So this means automating or engineering out the human involvement or human factors in design of plant. If we can't do that through a hierarchy of control, we move over to the right of the roadmap, where we look to influence or optimize the factors that can make the person make a decision or make a violation or a slip to recognize or acknowledge that those accidents can occur. And it is only then that we've gone through this full analysis that we can find the outputs of improvements such as changes to procedures, change to competency management, many others, and we develop that and implement that within our business. So next I'm going to dive into what is hierarchical task analysis, failure analysis, and PIFs, performance influencing factors, which all make up this process. So I'll go into these in a bit more detail, but in a nutshell, hierarchical task analysis, or HTA, maps out a task using existing procedures and frontline staff to reflect work is done. It's presented in a graphical format so that it can be analysed. We then undergo failure analysis, looking at each step of the task to understand what could go wrong and why. And then we can start to identify those factors that influence the person making those failures. So safety critical task analysis is complemented by the use of existing work procedures as its basis. But the caveat here is that this isn't a procedural review. It's just an input into understanding what the task is. And it must be viewed alongside a workshop of key stakeholders and a walkthrough and talkthrough on site. Only then can you get the benefits. It also needs to involve a multiple disciplinary team of human factors consultants, process safety experts, but most importantly, the people who carry out the task. It's very important to get the right people involved here so we can get the most value out of the analysis. It's a powerful tool to understand work is done. So this is a snapshot from a blog by Stephen Shorrock. It's really important that we understand what workers imagine could be or perceive to be. Managers can assume through fantasy or maybe sometimes ignorance the workers imagine as per the procedure. Work as prescribed could mean defunct rules and guidance in procedures that need to be reviewed. And workers disclose the more taboo area, but that's more behavioural in terms of what we do as opposed to what it says we should do. And it's that sweet spot of workers done, which is the gold for HTA, so that we can get to the nub of what can go wrong. So here's a snapshot of what HTA looks like. Its approach is extremely useful for understanding the task and how it's presented. Preconditions set out things like procedures and the type of personnel involved and the overall goal. So an example I did in the past was offloading of odorant at an offtake. You break down your steps and then a series of subtasks that make up the steps. It is then, once you've got workers done, in a format such as this, so that you can go through each to establish the potential for human failure. Is it going to result in a major accident hazard or significant incident being realised? If not, it can be screened out. But if so, you can then progress it to establish what is the possibility of human failure, what are the factors, and how can we optimise that to improve and remove that from the hazard being realised. So then we go into failure analysis, as I just briefly mentioned. So once you've mapped the task out as reflected as work done, you carry out the failure analysis using a Sherpa technique. We all love an acronym in the gas industry, so here's another one: systematic human error reduction and prediction approach. Think of it as a human HAZOP with a series of guide words organised into different task types, prompting us to analyse and identify possible failures related to different steps. So things like wrong action carried out, checks omitted. If you want to think of it really simply, it's like pressing the green button when you should have pressed the red button. So once we understand the different failures, we can identify the factors that influence our behaviour around them, the performance influencing factors. At the beginning of the presentation, I talked about person, job and organisational factors. Outputs from this type of analysis could suggest an example that certain maintenance is taking place in an environment not fit for purpose. Things like lighting and noise could play a part in us making mistakes, or it's being done at a time of day where we're at a higher risk of fatigue.
3 minutes remaining.
Here are some of the examples of PIFs. Have a go in the chat if you can think of more. I'm sure there are that we may experience in our day-to-day working lives. So to summarise, here are the 6 stages that make up safety critical task analysis. We need to make sure that we've got a good screening process in place to extract our tasks and identify and prioritise what needs to be analysed. Preliminary analysis using procedures to extract and carrying out a workshop to establish work as done versus work as imagined, and then going through the analysis of identifying failures and where it can go wrong with human involvement. Only then can we establish recommendations to improve it and integrate that into the business so that we can deliver those improvements. So finally, the benefits of incorporating human factors. It really is a positive step in reducing incidents and in health. Things like improved procedures, legislative compliance, improved competence identification, and also culture, putting people first and enhancing behavioural safety initiatives. There also are cost reductions to be achieved through enhanced productivity of work as done versus work as imagined, but removing regulatory enforcement brought up by incident. I'm very passionate about safety and customers and employees at Wales and West. It's an exciting time in the gas industry as we look at innovative ways to green our network and have a sustainable future. We strongly believe safety critical task analysis and human factors play a key part in ensuring a safe delivery of these goals, and we look forward to the journey ahead. Thank you very much. That's the end of my presentation. So I look forward to receiving your questions. Thank you.
Thanks very much, Jodie. Yeah, really insightful to hear kind of that element of the industry that you're working on. Judges, have you got any questions that you'd like to pose to Jodie, please?
Yes, certainly. Firstly, thank you very much, Jodie. I thought that was an excellent presentation. Having had the chance to, or having been involved in a couple of human factors issues myself in the past, it's definitely an area that I think we're going to see more and more of as we go forward. So my question to you is, quite early on in your presentation, you highlighted the sort of the step-by-step process going from May onwards, and about trying to engage the leadership buy-in, and you highlighted that you were able to do that. I've just wondered if you would be able to clarify a little bit more or expand a little bit more about how did you explain the benefits, or what did you have to do to kind of get that buy-in, because you know everything has followed from that point.
Absolutely, Ben. No, that's a really good question. Thank you. So It all began with becoming an informed customer, because it can become a bit of a minefield when you look at this type of analysis. It takes up a lot of resource and time to deliver. And I think where we unexpectedly had the HSE advise that this is the entirety of the network, not just Coma specific, I think there is a fear that this could become a cottage industry in terms of analysing. Is that going to drive? Is it just going to be another way that we manage risk? And that's what we don't want, because it doesn't bring a lot of value. So becoming an informed customer, being able to understand the true benefits, things like behavioural safety, influencing culture, but also getting shared benefits. I talked about management of change and fatigue management, which are already hot topics in the industry. So being able to see how that can be spread wildly across all the different areas using SCTA as a core, and showing exactly what the benefits are, and that it's prioritised based on specific screening. I think it brought some comfort to the exec that actually this is the right thing to do. Even though it was HSE driven, it's going to bring so many benefits that we can in the future see, especially with things like hydrogen coming on into the network. So it wasn't hard, but I think becoming an informed customer was a key part of that, Ben.
So turned a risk into an opportunity.
Absolutely.
Okay, thank you. Andy, would you like to go next?
Yeah, thanks, Jodie. Very interesting. Just kind of sort of leading on from what Ben was touching on there. I mean, I can see the perception that it might be a cottage industry given the number of potential safety critical tasks that you might have. But what I'm interested in is I can see very much the logic of the hierarchical assessment. It's when those circles overlap. How do you bring in the organisational factors? I mean, you mentioned management change, but the fact that so many things are going on around in the external environment or the work environment that are much less easy to analyse from a hierarchical point of view. But how do you bring in the fact that there's any number of different things happening while someone is also, from an organisational point of view, while someone's going to be approaching one of these tasks?
There's a few, thank you, Andy. That's a really great question as well. And I think there's a few layers to this. So firstly is making sure that I talked earlier about identifying safety critical tasks. So these can cover a wide range of areas. It can be operational task, maintenance, inspection, testing task, emergency response and upsets. So we need to make sure that we've extracted the tasks through existing safety case, HAZOP hazards, bow ties, existing procedures. And that's why we need human factors consultant at the beginning to get the methodology right and make sure that we've got a robust safety critical task register. We've identified all of our tasks, and it's identifying those crossovers before we dive into analysis, because you're quite right, it's going to be a lot of competing competing priorities in the future, because you do need those key staff involved in the analysis to identify the failures. So it's all in the planning, and it's about getting the methodology right before we start. And eventually we would like to become independent as well, and applying findings from one analysis across the board. So things central like management of change and fatigue can be applied wider as we go through the analysis, but then we become more efficient at it, and we develop human factors champions across the business that can help drive it. So it's a bit of a complex, that's probably a really short answer, sorry Andy, because I'm worried about time, but I think that's the nub of it, but it's about getting it right before we start, really.
Okay, thanks for that. I'd be interested to debate it further, but I don't think we've got time, so do see.
Just a quick one, Jodie, thank you. I also share your passion for competence, compliance and culture, because I think they're all interconnected. And you mentioned on one of your slides about one of the key factors being organisational change, and you based that on kind of we're in a price control period and net zero, but no mention of COVID and and the pandemic. So for me, it's right place, right skills, right time. Have you had to adapt some? I'm thinking purely from a competence, compliance, training. Have you had to? Has that been impacted around COVID?
Absolutely. I'm
very sorry, guys, to jump in there again. I'm doing another.
You've done it to me again, George.
No,
it's fine, Jodie. I'll
reply in the chat. Absolutely. Thank you, Lucy. Sorry about that, George, but thank you for your questions. If you want to probe me more, put it in the chat and hopefully I can discuss it further. But thank you.
Thanks, Jodie.
Yeah, and excellent questions, and I'm very guilty to cut them short. Certainly am, but yeah, we'll keep this moving. So from the southwest section, north to the northwest section, I'd like to introduce Michael Sinclair. Michael is a Cadent graduate engineer, and the title of his presentation is Hydrogen-Powered Construction Site. So over to yourself, Michael.
Thanks very much, George, and good afternoon, everyone. Thanks again for this opportunity. And I thought all the presentations I've seen so far have been brilliant, and good luck to everyone else that's after myself. So as George said, I'm Michael Sinclair, a graduate engineer with Cadent Gas, and the title of my project is Hydrogen-Powered Construction Site. Just a quick debrief about myself, get the boring bit out of the way first. I'm 24, I'm from Edinburgh, and I did my master's degree in chemical engineering at the University of Strathclyde in Glasgow. It's a 5-year integrated master's in Scotland. And then I went straight into the Cadent graduate scheme. And as soon as I got to Cadent, and to be honest, the thing that attracted me to Cadent in the first place was everything they're doing in the hydrogen field. I want to use my degree so that I can help sort of facilitate a sustainable future and help achieve net zero. So once I got to Cadent, I wasted no time trying to get into the hydrogen team as such. And that's where I am today. I'm sitting in the hydrogen strategy team, and I'm really loving it. So today I'll be talking about obviously my project on the fuel cell, and this is a breakdown of the topics I'll cover. So I'll give a sort of concept, some context to the project and the task at hand before opening up into the different options that we considered, and then finally into some results and also my personal contributions to the project before wrapping up with the bigger picture and how this all ties into our sort of net zero by 2050 goals. So I've got on screen here a picture of a typical construction site. If you just soak that in, there's just so much going on there. As you can see, there's loads of materials, there's heavy machinery, there's so many people that are driving to and from construction sites. There's such a big beast that needs tamed in terms of the environmental objectives we set ourselves to be net zero. And it's a really difficult sector to decarbonise. Roughly 10% of the UK's carbon dioxide emissions can be directly attributed to construction activities, and construction's not going anywhere. We're overpopulating, we're building new homes. We've got projects like HS2 that are going to be up until 2050. So it's a movable object that needs decarbonised just as much as any other sector. But where do we start with it? And this is now more prevalent than ever, as we've seen on the outcome of COP26 last month, that we really need to get a move on with our decarbonisation goals. So here at Cadent, we're very aware of this and we've acknowledged it. You might have seen 2 months ago, we published our 10-point hydrogen plan. And the very first point within that is related to construction sites, where we've set the goal of delivering our first net zero construction site in 2023. So obviously that's 2 years we've got to do that. And in the net zero world, in the green economy, that's really not that much time. So we need to get a move on, but we've set ourselves an ambitious target at Cadent. So what's the opportunity within that big picture? Well, there's an immediate opportunity for decarbonisation in the form of how you power your construction sites. So this is when your construction site is off-grid, and by that I mean it's not feasible to install a temporary connection to the electricity grid, so you have to find some form of producing your own self-sustainable power on site. And that's for all electrical appliances, as you can see for these welfare cabins, the likes of kettles, microwaves, electric heaters, even hot water sinks. Anything that requires electricity needs a power source on site. And typically this is just done through standard diesel generators. You would have seen these on fun fairs, or if you have been on a construction site, they're quite ugly, noisy things that are chugging away in the background, and they're terrible for the environment, but they're cheap and they're familiar. So the trial that we conducted was part of this wider development in North London, in Tottenham. So it's a £6 billion redevelopment called the Meridian Water Project, which this is a concept photo. This isn't what it looks like yet, but it's the sort of larger white rectangle. And our job within that at Cadent is simply to build a new pressure reduction station inside the red box there on your right. And once that's commissioned, we'll then turn off the old one in the yellow box, and we're good to go. And on this site, we had 6 welfare cabins. And to give you some context, that required about 35 kilowatts of power over 20 weeks. So the options we considered, well, of course, you can look at the baseline, which is your standard diesel generator. They're cheap, they're familiar, as I said, but they're terrible for the environment and they're noisy. So we can do better than this. We should do better. One sort of midterm solution is HVO, which is hydro-treated vegetable oil, which is essentially biodiesel. So it's still the same behavior at the end in the way that it produces emissions, but it's sourced from more renewable means in the way that it's come from degraded crops that have absorbed CO2 as they've grown. So you still have emissions at the tailpipe and they're still noisy, but it does reduce your overall net emissions somewhat. And then there's the exciting solution, which comes in the form of hydrogen fuel cells, which have absolutely zero emissions at the tailpipe as such. And another factor which is often overlooked is they're actually very quiet. And the benefit of this is you can actually extend your operating hours every day because you're not producing noise and unsociable hours. And then that way you can actually condense your overall project timelines by working longer hours. But they are expensive and they're unfamiliar. A quick crash course to everyone on fuel cells. Essentially, the way they work is they recombine hydrogen and oxygen at pressure, and the only byproduct is water. And within that reaction, electrochemical reaction, you produce heat and electricity in about a 50-50 split. But the catch is that it's very expensive in comparison to diesel, where diesel generators are cheap and diesel itself is cheap. For hydrogen fuel cells, the fuel cells are very expensive in capital, and hydrogen, especially green hydrogen, is also very expensive. So we're faced with this predicament of how much are you really willing to pay to go green? And that's a challenge that needs to be overcome. In terms of the project timeline, this was actually 8 months of planning required for this project. The concept was birthed last year in October, and we did 8 months of planning before the fuel cell was deployed on site in summer and removed in November. The most heavy part of that planning was the site design. Obviously, we had to make sure that we were abiding by all sort of legislation and CDM regulations and making sure everyone was comfortable with this new technology on site. And it was 20 weeks, as I said, that it was on site for. So I'm very proud to say that it did land on site. Deployment day was on the 24th of June, and that's a picture of it on our site there, both sides. And we were the first UK gas distribution network to utilise fuel cell technology on a construction site. So it is a UK first, and we were really proud of that. It was a really sort of satisfying moment after 8 months of planning to really see that fuel cell land on site, be connected up and start powering things in a green manner. And in addition to that, we also latched on to 22 kilowatt electrical vehicle chargers so that if anyone had an EV on site, they could charge it using green electricity, truly green electricity. And we also had a site van, which was used to sort of ferry equipment around, which was electric as well. So in terms of environmental savings, over the 20 weeks, we saved the carbon equivalent of dioxide of just over 20 tons, so 21.3 tons of equivalent carbon dioxide were saved just in 20 weeks. And on this graph here, it's our estimations of how much emissions would have been produced from the alternatives, obviously diesel being the baseline, but also HVO in the midterm. And that's the amount of fuel you'd have to consume above there to produce the same amount of energy. And to put that in perspective, that's the equivalent carbon uptake, carbon absorption of just over 1,000 trees over the 20 weeks. There is a catch. We did have to transport the hydrogen via HGVs. There is obviously no hydrogen network. We're working on it at Cadent. It doesn't exist yet. So unfortunately, they do have to transport their green hydrogen bottles via diesel trucks at the moment. But that doesn't sacrifice an awful lot of your carbon dioxide emissions. As you can see here, it's still the much more sustainable method. And if you're wondering why there's more deliveries of hydrogen, it's just because you can't store as much on site as you can of the equivalent energies just because of the density. So our recommendation from this trial, essentially, we think immediately we should implement HVO across all sites. I don't think there's any excuse not to. You're essentially just putting a different liquid into the same machine and you're still helping the environment and it's still price competitive. So I don't think the project scope from the start should have been, how are we going to get off diesel? We shouldn't have been on diesel in the first place. It should have been, how are we going to get off HVO into an even greener method? And that's where it leads us to the long-term solution that definitely is hydrogen fuel cells, in my opinion, and from the results of the trial going forward. In future, the units will be even smaller in footprint. They will be more efficient. They will become cheaper as the market expands. And we'll be ready for that at Cadent because we've got this learning from the trial. We know how they behave on site. And we've produced proper formal documents, the likes of the G23, which is essentially reapplicable for all future sites. So it's never going to be as hard or laborious as it was this time for us. It's only going to get easier. There's also opportunities to really improve our future sites and be smarter with our selection. We actually didn't use the fuel cell as much as we wanted, in the way that it was quite a hot summer and people weren't using the heaters as much. So we didn't actually really get the full use of it. And the way I like to describe that, it's almost like having a Ferrari, but all you do is drive it to the supermarket and back in third gear. So we didn't actually use this really smart technology to its full capabilities, but we can in future. And there's even a way to synthesize, potentially some solar panels to really supplement the electricity generation in another green way. In terms of governance, I can't sit here and pretend I've done this whole project myself. I have to give great credit to the rest of my graduate team. A team of 6 really great engineers who put a lot into this project. I was project manager, so the way I saw it was, if it went well, it was a great team effort, but if we didn't deliver this project, the buck sort of stopped with me. But we're all standing there in front of our work, and that was a really proud moment for us. And the way it was structured is, I was sort of the glue between the different stakeholders. In the way that we had our suppliers to fuel cell, we had the contractors on site, we had our own sponsors at Cadent that we were reporting to, and had to make sure we were engaging with all our respective teams that are relevant, safety teams, engineering teams, and even sort of commercial PR teams within Cadent as well. So there was a lot of moving parts to this project. In terms of the skills that I've gained, it was a bit of a baptism of fire, really, coming into the grad scheme straight out of uni and managing a project like this. A lot of deliverables, and it was a very unknown field. There wasn't a manual for how to get a fuel cell on site because no one had done it before. But that's the best way for me to develop, is to really get stuck out of my comfort zone. And it gave me a great insight into how to manage relationships, both internally and externally, how to manage a team over such a long project as well. Thanks, George. And just project management deliverables as well. And at Cadent, we've learned a lot from this trial. And that's the main point. We know a lot more about fuel cells now than we did before. And if you say it like that, then this trial was successful. Definitely, we know how these things behave. We know how they work on our sites because we didn't just research them. We went and did it ourselves. And there's a lot of upskilling within that. I don't think anyone within the business knows more about fuel cells than myself and the graduate team now, because we've worked on it more than anyone else. I'm quite proud of that. So how big can this really get? What's the big picture? You can see here in the bottom right, that's where our fuel cell was situated. And one site for 20 weeks saves 21 tons of carbon dioxide. What would it look like if we rolled this across the country? We typically have 20 sites equivalent to that active within Cadent capital delivery. So imagine we rolled out those fuel cells across 20 sites, and not just for 20 weeks, but all year round for 52 weeks. Then you're talking to the thousands of tons of carbon dioxide annually. I know sometimes those figures, if you talk in kilograms or tons, people kind of lose sight of the perspective. So to put that into more relatable terms, the one site that we did was enough carbon dioxide abated to fill up 4 whole Olympic swimming pools. And if we did the whole annual rollout of 20 sites, that's enough abated carbon dioxide to fill 220 Olympic swimming pools. So this is not small amounts. This is a really big picture. And as I noted down the transportation issue, we're having to use diesel trucks to transport our hydrogen. Again, we can help solve that issue as a gas distribution network. If we were transporting our hydrogen around the country using pipelines, because then we really are truly minimal emissions when it comes to sort of green power grids, and it minimizes the distance that they have to travel.
Final minute.
Thanks, George. So final slide, I think I can be very proud of myself and also the business that we're not just talking about going green, we're not just making commitments, then waiting for things to be market ready. We're not waiting for hydrogen to be on the shelf. We're actually getting out there and playing a part in the acceleration of hydrogen. We're getting stuck into field trials like this. We didn't have to do this field trial. We didn't have to experiment with hydrogen fuel cells. We chose to do it, and we've learned a lot from it. And I'm really proud of that we're helping to accelerate the growth of green development. I think everyone can sort of take a page out of that book, and then we'll be a lot closer to our net zero goals. So thank you very much for listening to me, and I'll be happily take any questions now.
Thanks very much, Michael. Really great presentation. So yeah, I'll hand straight over to the judges and see if they've got any questions for you.
Andy, would you like to go first this time?
Yeah, sure. I have all sorts of questions really, but first of all, congratulations on not only an excellent presentation, but an excellent project as well. I guess the most obvious one is so what next? How hopeful are you that what you and Cadent have learned here is going to go forward?
Yeah, thanks. Good question. And we're asking the same thing ourselves. So we're not just stopping there. We're actually doing Mark II of this trial, if you like, and that's a whole group of new graduate engineers from the new cohort. So they're going to try and do the same but better, which is exciting. So we're having calls with them already to debrief on our learnings. But in terms of barriers, we've proved from this trial that the technology does work. It can supply. There's no getting away from it. It's costs. It's just not cheap enough at the moment. If you wanted to roll it out across the country, and there's not enough fuel cells either. If we wanted to do this tomorrow across 20 sites, we couldn't. There's not enough fuel cells. There's not enough hydrogen, and that's a bit of a reality check for us that we need to get a move on. I think in terms of the hydrogen field that can be replicated not just to powering sites but across the board. We really need to get a move on and start accelerating this if we want to reach our goals.
Okay, well, thank you very much. There's all sorts of other questions, but I think I shouldn't hog it.
It's all right. Catch up after.
You can do, Andy, because I haven't. You said you were very proud, Michael. So you should be. You had me at the first slide, which was that construction site. I now know who to come to if I have any questions about fuel cells. And Andy, you kind of took my question really, which was, around the next steps, and you've already answered it, which is costs, I guess. So yeah, over to you, Ben. Thanks, Michael.
Thank you.
Okay, thanks very much, Michael. As the others have already said, a great presentation, really interesting project. You've touched on one of the main challenges already, which is the sort of availability of the hydrogen, availability of the fuel cells, etc. But you also highlighted the potential rollouts. I think one of the things that always strikes me with these applications is the security to supply. You need your power to be available all the time, and then therefore you need a certain volume of storage on site, and and so on and so forth. So I just wondered if it'd be possible if you could just expand a little bit further on. I mean, whether it be that specific example or going forward on other examples, some of the challenges and the balances between volume of storage on site, security supply, distance to where you're getting the hydrogen, and some of the limiting factors. So you gave an example of how we could roll this out, the whole thing. That's probably not as pragmatic because the hydrogen supplies are not that commonly available. So just wondered if you could talk about that a little bit.
Yeah, so to us at the moment, we can't do that much as a gas distribution network to facilitate the supply chain. That's more on the supplier side and the production side. But in the long term, the likes of HyNet we're doing at Cadent, if we can facilitate a 100% hydrogen network, then we're doing our part to reduce costs and reduce sort of supply chain stress in a way that you've got a network there that's carrying this commodity around. From their perspective, they are scaling up. There's more players entering this field, which is really good to see. There's more people that are going to be putting fuel cells on the market. There's more people that are producing hydrogen. And all that's going to do is increase competition, increase innovation, and that results in costs going down, which makes it more attractive to all customers. So it's going in the right direction. I think that tipping point, I'd like to see it around 2025. So that's why it's good for us to get this learning now, so we're ready to capitalize on it. And we're not just sitting waiting for that. We're going to try and Mark II, as I said. But it's exciting.
Good. Well, I think we've got a few minutes left, so I'll ask a follow-up question. Somebody had posted in the chat another good question, which was about the sort of the origins of the hydrogen. You know, because obviously, if we're truly saving emissions, then we get into the provenance of where the hydrogen's coming from, and so how was that sourced, and what's the sort of overall impact of that?
That's another great question, and it's another consideration we had. So we ensured that within our contract from our supplier, we were only going to use green hydrogen. So whatever hydrogen they gave us had to be green. But realistically, going forward, if we are going to implement this, nationwide, not just for fuel cells, but all hydrogen applications, it's not all going to come from green sources, at least not at first. We're going to have to supplement it with blue. But it's accepting that blue is still better than diesel. It's still better than hydro-treated vegetable oil. And you'd rather have your emissions at the front end, at a factory in the middle of nowhere where you're capturing the carbon, than right next to a primary school in the centre of London where you're getting nitrous dioxide, you're getting carbon dioxide. So it's steps in the right direction, but green is the long-term future.
Excellent. Thank you. I think that's our time. George has appeared.
It is, yes. Thank you very much, judges, and thank you, Michael. You have got another question in the chat, which I'd invite you to have a little gander at and answer in your own time. But yeah, thank you very much. A really good presentation.
Thanks all. Cheers. Good luck, everyone else.
Right, so moving through, we are on to finalist number 9, so the penultimate finalists from the 2021 YPPC final. So Suki Ferris is a hydrogen marketing strategy lead at National Grid and is the Midlands section heat winner. And her presentation is titled Hydrogen Guarantees of Origin. So over to you, Suki. Do you know you're still on mute? Oh, yes, super.
Yes, okay, I can see that now. Thank you very much. Can you see my screen?
Yep, all clear.
Okay, perfect. Is it full screen for you? Sorry.
No, it's still in. You can still see the pane around the outside.
Oh, okay. Is that any better?
It's clearer, but you can still see the tabs around the outside. There is the presenter button at the bottom right that you can try pressing, which is next to the Zoom feature. Or in the top left, there's a little presentation pane with a little play symbol in the middle, which I believe will also get it to start.
Sorry, so is that better then?
Yeah, that's the one.
Okay, perfect.
Perfect.
Thank
Over to
you.
you.
Thank you very much. Perfect. So good afternoon, everyone. My name is Suki Ferris. I work for National Grid Gas Transmission, and I am a hydrogen market strategy lead. Today I'm going to be talking to you about my project leading a hydrogen guarantee of origin project. So I led this project, and to deliver this project, I brought together an external working group, including over 70 members from across the gas industry value chain in the UK and the EU. This working group included organisations from over 30 companies, which you can see in the image to the right. Through the project, I delivered dozens of bilateral sessions with the external working group to gather intelligence and data on guarantees of origin. And I analysed this information to lead 4 working group sessions to discuss and debate a UK hydrogen GU scheme. So I'm now going to go into the details of why explore hydrogen guarantees of origin, and throughout this session I'll refer to hydrogen guarantees of origin interchangeably as GU. So why explore hydrogen guarantees of origin? First of all, we know that despite their differences, natural gas, biomethane and hydrogen all perform the same function. Burning these products generates energy. However, the important thing to consider is that they do have different climate value attributes, and that's why a guarantee of origin scheme is going to be essential to be able to track, account for and associate the climate value premium for these different gas products. Another reason why exploring guarantees of origin is going to be so important is because we know that extensive hydrogen goo work is taking place globally and in the European Union, which will likely impact our future cross-border trade. So, for example, we know that in the EU Commission has funded a dedicated hydrogen goo scheme project called Certify, and the UK is going to need to understand and keep abreast of EU hydrogen goo developments to benefit our future cross-border trade. And finally, it's really important to explore hydrogen guarantees of origin because a hydrogen guarantee of origin scheme is likely going to interact with existing UK climate value schemes, including renewable electricity guarantees of origin, the emissions trading scheme, and renewable gas guarantees of origin, which are biomethane GOOs. Now, it's really important for me to make a key note here to say that although at the moment we have a very mature electricity guarantee of origin scheme, so for example, I'm sure that everyone who's living in the UK at the moment is currently signed up to a 100% green or 100% renewable electricity tariff. And this tariff is actually backed up or evidenced by electricity guarantees of origin. However, the same is not true on the gas side. So at the moment, there is currently no legal basis for gas guarantees of origin, and there's no regulated gas tariff framework. And so reflecting on that last point, one of the key aims that I wanted to explore in this project was what role could a UK hydrogen goo scheme play in the development of a future UK hydrogen market? And the outputs of the project, including exploring the benefits of a UK hydrogen goo scheme and recommendations that industry could take forward to implement a UK hydrogen goo scheme. So I'm now going to build on the story and talk about how do guarantees of origin schemes work. But I'm first of all going to start with what do they look like. So as you can see in the figure on the left, guarantees of origin are essentially digital documents, digital certificates that include information on the origin, the source of energy products. So for example, where, when, how a particular energy product was generated. And one of the key aspects of a goo is that a goo can be traded separately or independently from the physical commodity. And in this way, goos can really maximize the climate value attributes of an energy product. And I also wanted to show you in this last image what a current biomethane goo looks like in the UK. And as you can see, it includes information on biomethane goo products. So now I'm going to go through how could a hydrogen guarantee of origin scheme work? And the first point to point out is that it's really key to note that a hydrogen goo market would be separate to the physical commodity market. So while buying a hydrogen goo wouldn't be able to influence the energy that you received at your meter, a hydrogen goo is instead a mechanism for consumers to make conscious choices on their energy products. So the core principle of GOOs is that for every 1 megawatt hour of energy production, 1 GOO can be issued. So for a hydrogen GOO scheme, for every 1 megawatt hour of low carbon hydrogen production, 1 hydrogen GOO could be issued. Once the hydrogen GOO are issued, they can be transferred from the hydrogen producer to the buyer of a GOO, and a buyer of a GOO could be an energy trader, an energy supplier, etc. And once the GOO has been sold to an end user, the GOO can then be cancelled to prevent any double counting. So now I'm going to talk through some of the key findings of the project in terms of how a hydrogen GOO scheme could benefit a UK hydrogen market. So first of all, I'm going to talk about the benefits that I explored that a hydrogen GOO scheme could provide to hydrogen producers. As you can see in this diagram, clearly a UK hydrogen producer would be remunerated for the physical commodity that they're generating. However, the sale of hydrogen GOOs could provide an additional revenue stream on top of the revenue provided from the physical commodity. which is a really key point to make, because without a certification scheme such as a GOOS scheme, there is no way to track, account for, or associate that premium for example, blending a low carbon hydrogen gas product, a low carbon hydrogen product within the existing natural gas networks, and there'll be no way to associate a premium for different hydrogen products within 100% hydrogen pipelines. Another key benefit for hydrogen producers from the sale of hydrogen GOOS is that the sale of hydrogen GOOS could provide evidence to hydrogen producers on consumer appetite for their product. And positive signals from consumers could provide hydrogen producers, again, with that evidence to justify increasing their production from their hydrogen production facilities. So moving on to hydrogen consumers, a hydrogen GOOS scheme could be a key scheme to encourage and incentivize consumers to engage in a hydrogen market. So for example, consumers could purchase gas tariffs or gas products backed up by hydrogen GOOS, and in this way indicate their preference for specific hydrogen energy products. And this is a really key point to make, because at the moment consumers do purchase 100% green renewable electricity tariffs. Hydrogen GOOS can enable the same thing for gas consumers. Gas consumers could buy gas tariffs backed up by hydrogen GOOS. And finally, I'm going to talk about how a hydrogen GOOS scheme could benefit hydrogen transporters. So a key benefit of a hydrogen GOOS scheme is that hydrogen GOOS could enable virtual trade ahead of physical change. I'm just going to talk about, to illustrate this point a bit more. So at the moment, we know that local councils and cities have made quite stringent carbon reduction targets for 2030. So, for example, Edinburgh Council has pledged to be a carbon neutral city by 2030. But when you consider the options for how a city or a council could decarbonize, electrification may seem like the easiest method. And that's because you can go out and buy a solar panel or buy a wind turbine and install it today. A local low carbon gas option, such as a hydrogen production facility, may not be so easy for local councils or cities to introduce today, or indeed by 2030. But if we use an example of Edinburgh City Council, you can see that through purchasing hydrogen GOOS, Edinburgh could demonstrate their commitment to decarbonising their gas use. So, for example, as you can see in the figure to the right, there are several hydrogen production projects in Scotland, and I haven't illustrated them all here. I've just illustrated some of the key projects. So, for example, Project Acorn and the Dolphin Project. And these projects are planning to blend hydrogen into the gas networks. And so therefore Edinburgh Council could purchase hydrogen GOOS and demonstrate their commitment to decarbonising in the same way that consumers today buy electricity tariffs backed up by electricity GOOS. Now, this can be seen as quite a controversial point because consumers don't have to change their energy behaviours or energy use. But my question in return to this is, if we can't use a market mechanism to demonstrate our commitment to decarbonise, what could be the time and cost implications of waiting for 100% physical renewable energy delivery? So now I'm going to go and discuss with you some recommendations from this UK Hydrogen GOOS scheme project. And these recommendations provide insight into how this project could be taken forward, and also provide an insight into the influence of this project on the gas industry. So through the project, we developed a range of recommendations, but for the purpose of this presentation, I've just selected 3 to take you through. So the first recommendation is on timeline. So we recommended that a hydrogen GOOS scheme is needed as soon as possible to align with hydrogen production. And that's because any gap between physical hydrogen production and a GOOS scheme could lead to market confusion, because there'd be no way to verify which users had consumed hydrogen, and it would be impossible to verify claims of low carbon hydrogen consumption. Second of all, we recommended that hydrogen goods role within market frameworks should aim to become a statutory mechanism, and that essentially is a recommendation that there should be a legal basis for gas goods, including hydrogen goods, and that there should be a regulated gas tariff framework so that consumers can go to their gas supplier and choose a green gas tariff. And third of all, a key recommendation is for a pilot hydrogen goo scheme. And this is a really key recommendation because a pilot hydrogen goo scheme could trial the processes and functionality of a hydrogen goo scheme, and also gain really valuable customer data on what information within hydrogen goos consumers find really valuable. So for example, do consumers find it valuable to know the exact carbon emission data from the hydrogen goo products? Thank you, George. And the last slide in this section, I will talk about the influence of this hydrogen goo project. So using the outputs and the recommendations of the UK hydrogen goo scheme project that I led, I was able to write and lead National Grid's response to 2 recent BEIS call for evidences and consultations. So the first request for input from BEIS was the consultation on a UK low carbon hydrogen standard. And I was able to use the output from this project to contribute to National Grid's response, because BEIS has included within the consultation that they are considering developing the UK low carbon hydrogen standard further into a guarantee of origin scheme. And therefore the outputs of this project exploring what a UK hydrogen scheme could look like, how it could work, recommendations to implement it, were extremely relevant. I also wrote National Grid's response to the BEIS call for evidence on designing a framework for transparency of carbon content in energy products. And that's because in this call for evidence, BEIS requested input on several key questions, including whether the existing regulatory framework for energy tariffs should include interventions for a green gas tariff framework. And therefore I was able to respond to that with the outputs from this project, as hydrogen goos could be used as evidence to back up a green gas tariff. So those are short-term influences of the project, adding this evidence and output to these 2 BEIS requests for information. Clearly, in the long term, the hope is that the outputs from this project will be able to help government make a decision on developing a green gas tariff framework for consumers to be able to participate and drive a UK hydrogen market.
Final minute.
I'll just really quickly, thank you, George, go through the key learnings that I took from the project. So first of all, I gained very quickly technical knowledge on guarantees of origin. I developed my stakeholder management and project management through managing a 70-strong working group project. And I also developed my confidence enormously by reaching out to new contexts in the gas industry to grow this project, and gaining confidence through frequent challenge and review of a constantly evolving and complex and at times controversial subject. So thank you very much for listening. I'm happy to take any questions now.
Thanks for that, Suki. I'll go straight to the judges then, please, for your questions.
Lucy, do you want to go first?
Yes, okay, thank you. Thanks, Suki, for that. A couple of things for me quite early on, and you've just in your last slide mentioned that stakeholder engagement. How easy was that? And you also said about potentially a controversial topic. And is there anything you've obviously, you're out the other side, and you've probably taken a breath. Would you have done anything or approached anything any differently?
Yeah, great. Thank you, Lucy. So in terms of the stakeholder management, I found that the project working group grew and grew and grew throughout the project, because this is a very new topic for the UK gas industry. This was a first of a kind project, so interest in this subject area is very large, and that's why there was such a large working group. It was a delight to work with the working group, honestly. Had very interesting discussions, and because the working group represented the gas industry value chain, it was great to get that input from, potential hydrogen producers, potential hydrogen transporters, and potential hydrogen consumers, including the suppliers who may be developing tariffs that consumers could sign up to, backed up by hydrogen goods. In terms of controversy, so some of the, for example, key controversial topics were, for example, the carbon emission thresholds that would make a hydrogen product eligible for a hydrogen goo scheme. So yeah, it's quite complex to be able to provide that information. So that was a good example of a controversial topic. And in terms of whether I would do anything differently, I was really happy with how the project went. I think for me it would just be more background research in the topic. Everyone always wants more time to understand more about the sort of history of hydrogen goos, and I had to learn all of that very quickly. So having more information to hand beforehand would have been helpful in hindsight.
Thanks, Suki.
Excellent. Thank you, Suki. Excellent presentation, an area that I think is often not really understood by the wider public. So very good to bring it to life, and some great presentation and recommendations, and also a very nice segue to the last chat we just had about the construction, where about their hydrogen was coming from. So very well linked up there. Nice segue. One of the clear recommendations you highlighted was how you've been able to input into the BEIS, call for evidence and contributions for National Grid, etc. But obviously that's only one piece of the puzzle. The UK continues on one way, Europe continues in another way. So what's next in terms of that, maintaining that collaboration between the UK and Europe, as we go forward, together? Yeah, absolutely, and ensuring a close working relationship with the EU is a key recommendation from the project. And in the hydrogen goose space, there are several key steps that the UK could take forwards. For example, we could become a member of the EU-funded hydrogen goo scheme project for the EU certified. We could become a member of that and keep abreast of their developments. There is in the EU an organisation called AIB, which manages the cross-border trade of goo certificates. We could become a watching member of that organisation and understand how the EU is managing cross-border goo trade. So really, I think it's about recognising that because of Brexit, we may be speaking with our EU colleagues less and taking steps to make sure that we are keeping up to date with EU hydrogen goo developments. Excellent. Thank you very much. Andy?
Yeah, probably a brief question, or at least a brief answer. You mentioned early on about separate trading of goos to the physical. Is that, and that intrigued me at the first, but is that essentially what you were describing later about drawing the parallels to the electricity scheme?
Yeah, so the physical commodity market will be concerned with, for example, the temperature of the gas, the pressure of the gas, the flow of the gas. On the goo side, it's different because it's a digital document market that's verified by the physical production of the energy product. And although that there is a legal basis surrounding the use of electricity goos in the UK, we don't have the same for gas goos. Right. So a big part of this project is how do we put those on equal footing?
Great timing. Thank you. I hope you're happy with that. But yeah, thank you, judges. Thank you, Suki. Fascinating presentation. So yeah, we'll swiftly move on to our final finalist of the 2021 YPPC final. How many times can I say finally? One sentence. Who is Luke McDonald? I'll just share my screen. Oh, it is. So Luke is a engineering manager at SGN. I've gone one too far. At SGN, and is our Scottish section heat winner. and he's here to talk to us today about the Stornoway odorant changeover. Over to you, Luke.
Thanks, George. Thanks, everyone. Before I get started, just hopefully the slide works. Just let me know if it's come up.
It's still loading on my end.
Okay.
It's up in this end.
George, are you?
I'm not seeing it, but if everybody else is, I can now.
You can? Okay, great.
Yeah.
Thanks, George. Okay, I'll start. Well, good afternoon, everyone. Again, thanks for joining, and thanks for having this opportunity. It's been really great so far. A lot of learning. As you said, my name is Luke McDonald. I work for SGN, and I'm the SIU Engineering Manager. And today I'll be presenting on what I'd like to title a new smell in the Hebrides. So this beautiful image here, this is a Stornoway LPG storage site. Stornoway is one of our 5 remote networks. We also call them Scottish independent undertakings, for those who aren't aware. These independent undertakings are off the grid. These are based, one in Stornoway, which is LPG. We have 4 others that we own and operate. One in Oban, Campbelltown, Wick, and Thurso at the top of Scotland there as well. The other 4 are LNG sites, storage sites. So Stornoway is slightly unique in that it's only LPG. The site has 540 tons capacity. This makes it an upper tier coma site, given the fact it stores over 200 tons of liquid gas. The actual size of the network, and give you a feel for that, fairly small network, as you can imagine. 1,800 customers that we serve, 15-kilometer network length, which is all now PE, which is good for us. And the actual site you can see there, we have 2 mounded vessels under the grassy hill at the front of the screen, and then only one of the above ground vessels is actually in use. This site, as you can imagine, does get a lot of attention from the likes of the HSE, given the risks associated with propane being heavier than air, and also obviously high pressure storage vessels, things like Blevy risks and so on. So the project background, what are we going to talk about? What did I do? Well, the screen on the left, the map, that's obviously Scotland, as you can see. Point A at the top left is where we're going to talk about. That's Stornoway, northwest of Scotland. Beautiful place if you get a chance to visit. Stornoway is and was odorized with tetrahydrothiophene, or THT for short. And this is the offload point. We moved to road tanker deliveries fully in 2012 for the site. And the site has taken stenched gas up until now, in that they've actually stenched their gas on site. The journey from point B to point A is 200 miles on the road and another 50-mile ferry journey, so a fair amount of distance there covered. Point B is our current supply terminal from Flowgas, which is in Grangemouth. This is odorized with ethyl mercaptan, EM for short. This loading terminal is we take our majority supply from here, and site operations up until this changeover were altered on site initially for our SGN loads, so they would accommodate our non-stenched product request. So what was the problem that we had? Well, the problem was the equipment on site was aging. It was unreliable, it was producing a lot of risks. We had hazardous goods on site. And in addition, obviously, as I've said, there's a huge distance to cover, which is containing unodorized LPG, which is not ideal and not too safe either. So what was the solution? Well, I was tasked with this project pretty early on and to come up with a possible solution. Obviously considered things like a replacement of odorant on site, i.e. the equipment. However, this was extremely costly, there was no like-for-like replacements, and we're getting very kind of resistant assistance from suppliers. What I chose to do was actually change the odorant, so begin taking newly stenched gas. However, the obvious issue with that is they're different odorants. This solution would allow us to remove storage and equipment from the site, and actually in that it was an innovative solution across the whole network, so we were able to remove that. Obviously, it would provide us with odorized gas across the full supply chain, and we would also save on capex as well, replacement of the aged equipment. So just a quick one on your screen there. That's the out with the old. That's the old equipment that we had on site. You can see the additional storage vessels, the storage vessel itself, a dosing vessel, and an injection pump. So behind the cabinet there, we have the offloading bay. The LPG tanker would come in, offload liquid gas. The injection pump would sense the flow and inject highly stenched odorant into the actual into the network prior to going into the storage vessels. So the actual program itself, an overview to say the least. Task at hand was simple in nature. However, there was a multitude of challenges that came my way during this whole project. The 4 key areas of the program that I'd like to sort of pick out are on the screen. These tested my ability to adapt, to work on new areas within both the industry, but also departments within SGN as well. So the scope, to start things off, I initiated a feasibility study myself by identifying the possibility of, could we do this? This must be stressed, it was a very unique piece of work, as there was no instruction on how to do this, and a lot of it was just figuring out as we went along. I identified this early doors as to if it was possible, and part of this as well was visiting the actual LPG supplier Flowgas to analyse their current testing and operational restrictions. The top left of your screen is a Gastech Gas 72L tube. That was a testing that the site would do in Flowgas, and this was just to gauge the concentration of the samples that they were putting out. Fairly accurate, not hugely scientific, but gives an indication. The top right of your screen, technical compliance. So British Standard 4250 is the specification for commercial propane. This had limited guidance on concentration, unfortunately, that I found out pretty early on. As a network, we're serving customers, and with odorant addition now proposed to be out with our control, this really needed a huge focus. The document itself had a huge focus on smell intensity. As an engineer myself, the perspective of this was sometimes difficult to grasp. I would have liked maybe a more scientific approach, but I needed to constantly remind myself and stakeholders of this. In addition, I obviously looked at different gas quality monitoring procedures that SGN follows, such as GQ6, GQ2. And within those, again, there was a huge focus on actual smell intensity and from the network side of things. There's very few networks of propane, particular size. So there was definitely little interest in the industry in the past. So again, I was perhaps pushing addressing some issues that no one had ever addressed. And I did also look for some third-party assurance via DNVGL, who undertook and assisted us, or myself anyway, with an additional technical report, just to ensure myself that what I was doing was actually indeed correct and compliant. The third element is an operational element, so the stock management on site. As I said, we have 540 tons of LPG on site of an old odorized gas. So we needed to figure out, and I needed to figure out, how do I manage this program of changing, rotating this? So the stock rotation was a big one. And one of the things I really wanted to do was minimize mixing. The reason I wanted to do that was I did not want the customers to feel confused with different smell of gas. And obviously the main importance is they need to identify that what they're smelling is indeed a gas leak. So I proposed a phased loading approach where we reduced the stock from one vessel and then restocked it and just managed the loads as and when we needed to with in assistance with the site operatives as well. So implementation, how did I do this? Well, one of the big challenges of this was, how do you describe a new smell to, quite frankly, customers who don't know much about gas? They don't have a huge interest in gas. They don't know much about gas odorant. All they know is I have a gas leak. And that was one of the things I needed to address. Now, the first thing I looked at was the feasibility of a scratch and sniff card. You've probably all heard of scratch and sniff cards. As you can imagine, not a huge supply in the UK for these, for ethyl mercaptan. So unfortunately, that idea, although I thought it was a good one, had to be binned. I ended up going with public letters and a media release, so local public news and also SGN media. I developed and issued a letter to the corporate comms team within SGN. And as you can see, we've got 3 local papers that covered this story, and also the SGN social media. So there's a couple of kind of headlines on the screen that you can see from the local papers. What I agreed on with obviously our stakeholders, the best way to describe the new smell was decaying vegetation or rotting cabbage, is what we also looked at. This was agreed, however, as we all know, with nowadays fake news and a lot of different journalism thrown in there. One of the papers, Hebridean News, actually called it smelly. So the new smell, described it as smelly socks. So there we go, bit of humor. So just another element was the intensity. I felt this was the best to include this across a timeline of key points within the project. So firstly, probably familiar to some or a lot of you on the call, our local operatives are trained rhinologists, we call them. So essentially this means that they have calibrated noses. I utilise our operatives throughout the changeover programme, and with reference to obviously as I said, our gas quality procedures, the SALIS scale, which is on the bottom left of your screen. This SALIS scale is internationally accepted scale to use for whether odorant is satisfactory or not. So the minimum from the British standard 4250 was around 14 parts per million. That was the figure that I worked with initially. However, it did have a heavy reliance on the smell being distinctive at 20% LEL. I decided to take loads slightly above the minimum initially to monitor progress, with intention and gradually increase that if we felt it was maybe weak. We'd rather be strong than obviously be on the weaker side. So across the timeline here then, around August I initiated the stock drainage, and then September I issued the first letter with intention of changeover at the end of October. We took the first load in the 1st of October at 22 parts per million, and then in November, given the fact we're running into our winter season, I really wanted to begin the restock, given the fact we take about 5 loads of a 24-ton tanker every single week. So it's a heavily busy time for the site. As I said, and I mentioned, the daily sniff tests were done by our local rhinologists. And then I did a follow-up letter just to ensure the public that is now in the network and it is now sitting, there should be a new smell that you should begin to smell. Around January then, I wanted to get, following a bit of site feedback on slightly lower, slightly weaker smell through the odorimeter. On the bottom right of your screen, an odorimeter is an old piece of equipment that we use to monitor gas smell. There's 5 test network points across the network where we can hook up, run it through a gasco seeker, get 20% LEL, and then the guys can smell it for themselves. Following a bit of reports of it being slightly weak on the 20% LEL, I wanted to get third-party assurance from, again, DNV, who are heavily involved in this area in the industry. I engaged with what I like to call the best nose in the UK. His name's Dr. Brian Strungwell, for anyone who doesn't know. He did come up on site and he did confirm it was indeed satisfactory, which was good news for me. We looked to actually increase the trial up to about 60 ppm. And again, we continually monitored that in the network to ensure the odorant was strong. So further testing, I increased the quarterly lab sampling for about, I introduced quarterly lab sampling. Again, I wanted additional support from laboratory. I wanted to confirm that what flow gas were doing was accurate. So we gradually increased, we noticed a gradual increase in the ppm that we did request, and also that relayed into the network as well. We did also take a liquid sample. This was taken in a pressurized cylinder, you can see on the screen. Took that directly to the lab. Now, for obvious reasons, there was difficulties and risks associated with working with pressurized
3 minutes remaining.
gas. Thanks, George. So yeah, this was something that I didn't want to continue doing very frequently, given the risks associated. One of the things I need to stress, there's real lack of mercaptan historical data. As we know, throughout our gas procedures, we have a vast range of figures and injection rates to associate with. However, in Stornoway being very unique, this is really a world's first for working with DNV and producing a reference test gas that we know corresponds with injection rates and actual smell on the outside of the network. So that's something, again, that with these new lab samples that we're continually getting every quarter that I've introduced, I want to gather the data, which we are continuing to do with the site team as well, to then actually incorporate a new reference test gas and begin adding this to our current procedures already in place. So finally, where are we just now? Well, the current position, the changeover was indeed a success. It's something we've been monitoring as we've gone on. It is now settled in the network and the customers are well aware of this. I am developing, as I mentioned, the world's first reference test gas in conjunction with DNVGL, which will be used in our own rhinology work, but also other rhinology work across any other networks or any other LPG works that go on across the industry. The odorant equipment is indeed decommissioned and now removed from a site, which removes another hazardous good that we don't want. Industry learning, well, these are common learning points I've already seen across the industry. However, for myself, it was good to see how we actually, how these are brought in and see them in reality. Gas odoring monitoring is definitely a difficult science. And the nonlinear relationship between the concentration and the Salas scale, so if the smell is satisfactory or not, was definitely obvious throughout this project. Finally, for me, personal learning. I was the sole responsible person for this project. This project was critical within SGN. It was viewed as such, given the fact that odorant is the main point of determining a gas leak. One of the first things that's looked at is odorant if there's any gas explosions, and that was something that was key in my mind the whole time. Thank you, George. So for me, the leadership and the key decision making was something I really learned really quickly in this. And finally, just the stakeholder engagement side. I was able to interface effectively with customers, with contractors as normal, but it pushed me out of my comfort zone to engage with, as I said, some customers, other stakeholders, PR team within SGN, our comms team within SGN, all these different things and also local news outlets and things. So there's a lot of learning, a lot of contacts gained, and yeah, overall the project was definitely a success. So again, thanks for your time. I appreciate you've listened to a lot of presentations today, and I'll just now conclude and welcome any questions as well from the panel. Thank you.
Great, thanks for that, Luke. Really insightful presentation. Over to yourselves, Ben, and the panel for some questions.
Excellent. Thank you, Luke, for an excellent presentation. As somebody with personal knowledge of that site over many decades, I can fully appreciate some of the challenges that you alluded to in terms of records and the like. I suppose my question, I appreciate it's a very specific project in a very specific area, but I think it does show some good learnings around about changing of odorants, and we're obviously throughout today seeing presentations about other upcoming changes onto the gas network. So my question is although that might be specific to LPG, etc., is there broader learnings in terms of processes and procedural elements that can be applied to the sort of upcoming changes in the gas industry with the increasing role of biomethane and introduction of hydrogen and blends, etc.?
Yeah, thanks, Ben. That's good to hear you've got a bit of knowledge on the side as well. Yeah, it's a good question. I mean, for me, there was a lot of learning. I think the thing that surprised me was the lack of interest or knowledge from the industry. So that's one thing that would be interesting to see for the new networks. Does the industry have an awareness of if we do need to use new odorants? Are they aware of that? And have they clarified things like the Salas scale, injection rates, and so on? So that's definitely one thing. With this project, all I can really say in terms of LPG is definitely very little information. And trying to find and source that information. There are some world experts. There are some guys like DNV who are good on it. But other than that, yeah, it's maybe a weak point. So the huge emphasis on, we could talk about injection rates, we could talk about concentration, ppm, and so on, but the actual smell at the end of the day is the important thing, isn't it? And it's easy to get involved into, you know, the details of things like that. So that was a challenge for me, but yeah, it'll be interesting to see. I know some of the presentations have talked about hydrogen and how we can keep the same odorant. So definitely something I'll be keeping an eye on, and if I can assist or if I can get involved, I will definitely be looking to do that. So
brilliant. Thank you very much, Luke. Andy, over to yourself.
Okay, thanks. Thanks very much, Luke. Fascinating, and wake up and smell the gas will stick with me for a while. I'm not sure as a slogan it has its advantages, but what was the biggest challenge in this? I mean, was it technical or was it social? Customers? What would you say the biggest one was?
Yeah, there's definitely many, but I think customers was a challenge. However, with that one, we were able to sort of, I was in control, I guess, of what we were doing and how we were implementing it and so on. And we were be able to get feedback. I think the biggest challenge was, again, as I mentioned, the lack of assistance or knowledge from anywhere else. So there really wasn't a manual to how to do it. You know, I had to figure a lot of it out myself and seek assurance or third-party assurance quite consistently, because I wanted to make sure what I was doing was, at the end of the day, was compliant, and also, you know, at the end of the day, the customers are going to smell gas. So that was probably the most challenging, definitely. Yeah.
Okay, thank you. Lissy?
Just to echo everybody else, I salute you. I applaud you. I too have taken away the smell of gas as a headline. Would you have done anything differently, Luke? I mean, obviously you're out the other side. I was going to ask the question about you identified the challenges and grouped them into four, which would have been, you've answered that. On reflection, is there anything that you would have done differently? I mean, they always say hindsight's a wonderful thing, isn't it? But is there anything you would have done differently?
Yeah, there's probably a few. I think probably the main one was getting a bit bogged down in the actual data. And as I said, and as an engineer, it's easy to jump into the data and the scientific and the why and the why and the why. For me, I would say I took up maybe a lot of time in that, and I probably could have focused a bit more heavy earlier on the actual smell at the end of the day, if that makes sense. You know, they're the same but slightly different. So that possibly still getting focused on that. It's your, you know, as I said, as an engineer, you're always seeing the number, you're thinking it's maybe going to be a bit high, bit low. So probably just allocating maybe more time to that, more effort when I maybe didn't need to as much. That's probably the biggest change, but got there in the end. So
thank you, Luke.
Thanks.
Well done.
Thank you.
Super. Thank you very much. Yeah, thank you, judges. In which case, then that leaves me to say, yeah, thank you, Luke. Well done.
So
I shall just share my screen once more time. So now we will be taking a short break to leave the judges to have the unenviable task of deciding who is the 2021 victor. It should only take about 30 minutes or so. I think we've got in the calendar to reconvene, yes, at 1:45, where we'll be revealing the winner. So hopefully you can all join us again for then. But until then, enjoy a break, have a cuppa, have your lunch, and we shall speak to you all at 1:45. Thanks very much.